let's talk about domain and range. So the examples they've got up here, they've shown you how to switch it from set builder notation to interval notation. This is where interval notation really makes your life so much easier. I think it's easier to tell what's happening. So if we look at this graph, remember that the domain is all the possible x values. So if we were to imagine like taking our pencil and sliding it across the graph, everywhere that your pencil might be that it's going to touch the graph, that covers the domain of our function. So that's kind of a nice tool sometimes. I noticed that the first place my pencil would hit would be right here at -4. And then as I go along, I've got graph, 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 until I get over to here where it stops. And then that would be the end. Anywhere that I were to drag outside here, I wouldn't touch anything after that. So the domain starts at -4 and goes to 2. Since these are solid dots, those are both included, so we can write the domain using the interval -4 to 2 included on both sides. You just turn your pencil horizontally and slide it up and down vertically to figure out the range. And we always decide open circles on a graph represent parentheses, not equal to. Closed circles represent brackets. So let's look at a couple of these that are pretty straightforward. So I'd like you to try A and B as a quick little warm-up for yourself, seeing if you can identify the domain and range. And I'll post answers in a couple seconds. All right, here's what we got for the first two. So our domain, if we think about our x's, the first place that we get an x value is here at -2. Then if we think about sliding this line across the graph, we're going to always have an intersection until we get to this point right here. Outside of there, there's nothing else. So that's the only place we care about on the graph. That's from -2 to +1 is where we have graph happening. Because there are solid dots on both sides of the graph, we want brackets on both sides. Now with the range, if I think of a horizontal line, the first time that it would hit the graph is here at y equals 0. I'm on the x-axis, so y is 0. Then I slide this line up, and I'm going to keep touching it until I get to right here, which is 3. So 0 to 3. And again, closed dots, we're going to keep all of it. So D is a little bit different because we have an open dot on one side. So for the domain, we go from -2 to 1, but -2 is not included, so that's why we use parentheses. And then for the range, we go from -1 up to 2, but again, 2 is not included, so that's why we use parentheses on those two. C, D, and E are a little bit more interesting, so let's take a second to talk about those. So for C, the question is the domain, all right? So same kind of idea. Let's figure out where our first place is. And I think we can all agree that the first place that we're going to encounter the graph is at -3. But then if I start sliding this line along, it's going to touch, touch, touch until it gets to this open circle right here. But the good news is that where there's an open circle there, it jumps up to a closed circle. The closed circle fills in the open circle, not in the same spot, but that means that -2 has been counted because there was a solid dot somewhere. Then we're good until we get to this open circle at -1. -1 is not counted right there, but oh, guess what? It is counted right here. And then we go and go and go until we get to this open circle at 0. So even though it jumps around, the domain is that we've covered everything from -3, which was a solid dot, up to 0, which is an open circle. The range is much more interesting here. Because if we think about this horizontal line, the first place it's going to encounter the graph is right here at -3. But then if I keep sliding this line up, it doesn't touch anything else again until it hits at -2. And then similarly, it doesn't touch until we hit -1. So instead of having an interval of y values, there are only 3 specific y values that we can ever get to. So the range for this one is just -3, -2, and -1. That's not an interval. That's just a set that's a list. An interval is a set, but this is just a rostered out list. So that would be our range, because we don't get all of the numbers in between. The interval would include the numbers in between, which we don't want. If we look at D and E, they're both kind of interesting in a similar regard. Again, they got cut off a little bit. It copied kind of funky, and I'm sorry about that. On D, we have two asymptotes. So the graph is going to get really, really close to the asymptotes, but it's never going to get there. So if we think of a horizontal line, now another assumption you can make, because anytime you see a graph that's been made using graphing software, they very rarely put in the arrows. But we can make the assumption, because it goes all the way to the edge, that these graphs have arrows. If they don't have a dot specifically drawn, we're going to assume that it keeps on going. So that's the same for E. This is going to keep on going, and this is going to keep on going. We can make that assumption because it didn't specifically like end it with a dot at the end, okay? So if we look at D, if we imagine our horizontal line, it's going to hit everywhere along this graph until I get to the asymptote. It's going to get really, really close to the asymptote, but it's never going to get there. But it's going to touch everything else. So for the domain, we're starting at an arrow. The first thing I encounter is this arrow right here. So that means our domain starts at -infinity. We're looking at the x's, remember, left to right. And then we're good until we get to the asymptote. So our domain is good up until we get to -2. And we never get to -2 because it has an asymptote, so we're going to parentheses that. But that's not all of our function. We also have this whole segment on the right that starts just on the other side of -2 and then goes to an arrow, so it goes to +infinity. The domain is one set. The domain is one set of all possible x's. And right now we have two separate intervals. So the way that we show that these two intervals belong to the same set is to union them together. That now says this collection of terms are all part of the single set that is the domain. So go ahead and try then, see if you can figure out how we would write the range using a similar strategy. So what we should get for the range is that we start at -infinity and then we have to jump off at -1. Union, we jump onto the other side of -1, infinity. And these match, and that's okay, because all we did, since there are parentheses on both sides, is we hopped over it. It would essentially be like if you thought of a number line here. If I had -1 right here, but I shaded in literally everything else. I can get real close to -1. I just can't ever get there. So part E kind of combines both ideas from example C and example D. So I want you to put the video on pause and do a quick little brain check. See if you can determine what you think it's going to be. Answers coming in just a second. All right, this one was tricky. So if we're looking left to right, we start at an arrow, then we go to the right, to the right, to the right, and I get to an open circle, but there's a closed circle that I can jump up to before I move on and get to another arrow. So that's why it's -infinity to +infinity. Our domain covers everything. However, our range starts at an arrow and goes up until we get to 3. Oh, whoops, I meant to write 3, not 1. It should be a 3. It goes up until we get to 3, but there's an open circle at 3, so it's not included. And then we don't get to any of the stuff in between until we get up to here, and this y value just stays at 4 all the time. So again, it's not an interval, it's just a single set that has the number 4 in it, and that's how we would write that, okay? The last thing in these notes is finding intercepts using your graphing calculator, which we practiced the other day. So I'm going to leave that one for you to maybe try yourself and check your answer using the PDF. And I'll see you guys soon.